Hello, everyone. Today we're doing a slightly different topic. We're going to talk about congruence transformations, also known as rigid transformations or isometries. Is one in which the position of the image may differ from the original, but the two figures remain congruent. So this just means if I do a reflection or a flip, as shown in our first example here, that these two triangles are still congruent because all I did was reflect it over that line. Second is a translation, which is another word of slide, which means these two triangles here are still congruent because all I did was slide it. And lastly is a rotation or a spin. So all I did was spin it. All congruent triangles can be made from another one by doing one of these transformations or a combination. So I want you to pause and identify the transformation that's done on each of these three. So 1A is a reflection. It flipped over the x-axis. B, I actually rotated. And C was just a slide, so it's a translation. And that's really all we're doing is identifying which is which. So now example 2, I want to show that JKL with those vertices underwent a transformation PQR to get those. And I want to show that identify the transformation and verify it's congruent. So I want you to pause and plot them both and see if you can figure out the transformation. Okay, so I paused and I plotted both those, and hopefully you can see what happened from the purple to the pink is a rotation. Now to verify that they're congruent, this is where there's a lot of work. To verify that they're congruent, I need to show that all three sides of one are congruent to the three sides of the other. So if I want triangle JKL to be congruent to triangle PQR, that means that JK equals PQ, KL equals QR, and JL equals PR. So how I can show those are congruent is by doing the distance formula. So I'm going to do the distance formula for JK. So D, the distance formula to remind you, do it over here, is D equals the square root x2 minus x1 squared plus y2 minus y1 squared. So JK is the square root of -2 minus -8 squared plus 2 minus 5 squared. I do that on my calculator. And I get 6.7082. Now I'm going to do the same thing for PQ. So PQ is the square root of 2 minus 8 squared plus -2 minus -5 squared. And I do that on my calculator, and again I get 6.7082. So I verified those two are equal. I want you to pause and verify the other two pairs are equal, and then come back. So as you can see, I found KL and QR both equal 4.1231, therefore they're the same. And JL equals 4.4721, and so does PR, so those are the same. So those triangles are congruent. So it's a rotation, and I verified they're congruent. So that's it for today. If you have any questions, please bring them to class tomorrow.